Okay, so we're going to look at some other identities. These are the sum and difference identities. So this identity here says that we have the cosine of an angle minus another angle. So cosine of A minus B. I can rewrite it as the cosine of A times cosine of B plus sine of A, sine of B. So I would call this side here of the equation the expanded form. And sometimes we'll take the expanded form and we'll be able to simplify down to this collapsed form. And sometimes we need to do the opposite way. So we'll use both ways, but just knowing that this expression is equal to that expression will help us solve some problems, okay? So before we start, a couple things you need to recall. The distance formula, instead of D, I'm going to use a C, is the square root, of x minus x squared plus y minus y squared. That's our distance formula. And really, we might end up just really doing c squared is this. If I square both sides of that formula, it'll just make it a little easier what we're doing today. Okay, normally you'd square root it to get the actual distance between 2 points. These should have little 2's and 1's on them. All right, and then also the law of cosines, which says c squared is a squared plus b squared minus 2ab cosine of theta. I didn't give myself enough room. So this is distance formula. And this is the law of cosines. These have to do with like distances. Law of cosines has to do with side angles and measures of side lengths of triangles and measures of angles and stuff like that. So we're going to use these two things. And the reason I made the distance formula equal to c squared is you can see then I can write, once I have both of these things written out, if they're both equal to c squared, I could say the distance formula between 2 points can be written as equal to our law of cosines if we have the same angles and everything, which we're going to have in this picture, but whoops, yeah, theta. All right, so kind of we're going to use them. We want to make them both equal to c squared, so in the end we can make them equal to each other. So this is the identity that we're going to prove. So first we'll start with a picture. This picture is on an XY grid. I forgot to put that on there. All right, and we're going to take and look at the coordinates. We're going to do the cosine of angle A minus angle B. So since we have an angle A and an angle B, we're going to say that this angle here is angle A. And then we'll say this angle here is angle B. So then this angle here, the red angle, will be the angle A minus B. And what we're going to do is we're going to find the distance connecting these 2 points in 2 different ways. And we're going to call that distance C. Okay, looks like I have a phone call. Sorry. Hello? Yes. 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 Okay. Bye. Okay, sorry about that phone call. All right, so we're going to find this segment, the length of this segment. We're going to express it in 2 different ways. The first way we'll do is distance formula. So to do distance formula, I need to know the coordinates of this point. So the coordinates of this point, since it's angle B, the coordinates of this point are going to be cosine of angle B, sine of angle B, right? That's the x and y coordinates of that point. One way to express it. Oh my gosh. Hello? Yes. No. Oh boy, I gotta call you right back. I'm in the middle of making a video. All right, I'll call you right back. Bye. Sorry guys, hopefully that's the last phone call. Okay, so the coordinates of this point over here, that's gonna be angle A, so it's gonna be cosine of angle A, and the y value will be sine of angle A. Okay, so to find the distance between those 2 points, I'm just going to use these coordinates. I'm going to say like, the x minus the x and the y minus the y, and I'm going to put it in this distance formula, and I'm going to use this version here, c squared. So that distance c, well, I'm going to really just say c squared equals the x minus the x squared, so cosine of A minus cosine of angle B squared plus the y's sine of angle A minus sine of angle B squared. All right, and then I'm going to simplify this thing. I'm going to need a bunch of room, so I'm going to even just buying a little bit of space there and maybe making this a little bit smaller. Okay. So if I multiply this out, cosine A minus cosine B squared, that's going to be cosine of A minus cosine of B times cosine of A minus cosine of B. And then it's going to be plus sine of A minus sine of B times sine of A minus sine of B. I'm going to kind of zip through this multiplication. You can pause it and try to figure out how exactly I came up with it. But when I square the first part, I'm going to get cosine squared of A minus 2 cosine of A cosine of B plus cosine squared of B. And then plus, I'm going to get, now when I square the second part, sine squared of A minus 2 sine A sine B plus sine squared of B. All right, so now I see that I have, let's look at this. I've got a cosine squared A and then plus a sine squared A. By our Pythagorean identities, I know that cosine squared plus sine squared equals 1. So I can just replace those with a 1. Cosine squared plus sine squared equals 1. Plus, now I notice that I have a cosine squared of B plus a sine squared of B. So when I add those together, cosine squared B plus sine squared of B is 1. And then I have a minus 2 cosine of A cosine of B minus 2 sine of A sine of B. All right, so there's not much more simplification I could do. I guess I can add the 1 plus the 1 and get 2 minus 2 cosine of A cosine of B minus 2 sine of A sine of B. So that's one way to find what C is equal to. And I know I have C squared here. I could square root both sides, but C squared is going to be better. Okay, law of cosines means if you take the given angle, so like this angle right here, A minus B, and the side opposite C, if I use those two angles, so the angle that we're going to use is A minus B, and the missing side is C, because we know these two side lengths are 1 and 1, right? This is 1 and that's 1. And that's going to be our side A and side B in our law of cosines. So for our law of cosines, I'm going to get C squared. That's the side I don't know, so I'm going to leave it as C squared. I know the other two sides of the triangle are A and B. So it's like, this is really Pythagorean theorem. See it here, C squared equals A squared plus B squared. But it's for all triangles, even if they're not right triangles. If they have a different angle, you have to put this part on. So that's all law of cosines is. It's like the Pythagorean theorem for non-right triangles. You can see that because if I have a right triangle, the angle theta is 90 degrees. Cosine of 90 degrees is 0. 0 times all this crap is 0. So all of this goes away. So when the angle becomes the right angle of 90 degrees, all this goes away and you have just this Pythagorean theorem. But when it's not 90 degrees, you have to have all the rest of the stuff. So A and B are the two other sides of the triangle. I plug them in here, 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 and here. So now we're going to find that length using our law of cosines. So C squared, we don't know what C is, equals A squared, which is 1, plus B squared, which is 1, Those are the two other sides of the triangle, the 1 and the 1. And then minus 2AB, so those are the sides again, 1 and 1, times cosine of the angle. Now this angle in here, from here to here, is A minus B. It's the big angle minus the small angle. I'll be left with that angle measure, which is A minus B. All right, so if we simplify that, we get c squared equals 1 squared is 1, and then I add those together, I get 2 minus, this will be a 2 cosine of A minus B. So then, if I make these two equal to each other, because they're both equal to c squared, let's do that. So first I'll write out my distance formula when it was this guy up here. I'm going to write this out again. 2 minus 2 cosine of A cosine of B minus 2 sine of A sine of B. I need to put that somewhere else because I want to make it equal to. Whoops. So I'm just going to bleed into the bottom part of the page. The bottom, the next example, whatever. Equals this part right here, 2 minus 2 cosine of A minus B. First of all, I could subtract 2 off both sides of my equation and get rid of those. So now I'll have negative 2 cosine of A cosine of B minus 2 sine of A sine of B equals negative 2 cosine of A minus B. Now, if I divide both sides by negative 2, these cancel. And this negative 2 has to divide into both parts, so these cancel. And finally, I have cosine of A cosine of B plus sine of A sine of B, because I divided by negative 2. So don't forget, the negative 2 divided by the negative 2 turns into a positive, just like it did over here. When I divide these negatives, it turns into a positive. Equals, same thing here, cosine of A minus B. That was a nice little demonstration and a proof of that identity, which we saw all the way up here. I just had the opposite sides. I should have flipped the sides. I see that cosine of A minus B equals that. Now from that, we can derive other difference in sum identities. So this is called the cosine difference identity. It's a cosine, and it's the difference of two angles. How do we use it? What if I had to find cosine of pi over 12 without a calculator? That's not an angle we know. So I can think of cosine of pi over 12 as cosine of two angles that I do know. Cosine pi over 4 minus pi over 6. That equals pi over 12. You can just trust me. Now using my distance identity, difference identity, this is a difference where angle A is pi over 4 and angle B is pi over 6. Right? That's the difference of those. So I can rewrite it as cosine A, cosine B. So cosine of pi over 4 times cosine of pi over 6. And then it's plus sine of A, sine of B. So I can go sine of pi over 4 times sine of pi over 6. So now I can figure out what cosine of pi over 12 is equal to, because I know cosine of pi over 4 is root 2 over 2. I know cosine of pi over 6 is root 3 over 2. Then I know sine of pi over 4 is root 2 over 2. You can come in. And then sine of pi over 6 is 1/2. And then I can multiply these together, so I can get like root 6 over 4 plus root 2 over 4. So that'll be root 6 plus root 2 over 4. We can leave it that way for now. Whatever, that's fine. That's a way to calculate cosine of pi over 12 without a calculator. So we can use a difference or a sum identity for that reason. Now we want to demonstrate the cosine sum identity. So it looks just like the cosine difference identity, but now we have a plus. So what I'm going to do is I'm going to use the new identity. So I'm going to write cosine of A minus negative B. All right, and so now that will be the difference identity, right? So our difference identity, we just said that if you have an angle minus an angle, so in this case, A in our formula will be the A, and B will actually be negative B in our difference formula. So in our difference formula, it was cosine A, cosine B plus. So we're going to write this as cosine of angle A, cosine of angle B, which in this case, we're calling it negative B, because we wanted to turn it into a difference to use our difference identity, right? Plus sine of A times sine of our angle is negative B. And then it said to use our even and odd identities. So now we could simplify this as to cosine of A, and then cosine of negative B, that's an even function. So that's just going to be positive cosine of B, plus sine of A, and then sine of negative B, that's an odd function. So sine of negative B is equal to negative sine of regular B. And so that's multiplication. So the positive sign times the negative sign, I'm going to get a minus. So it's going to be cosine of A, cosine of B, minus sine of A, sine of B. And that is going to be our cosine sum identity. So that is our cosine sum identity. Very, very similar to the cosine difference identity. Of course, we can use this. We can use this to then figure out, like, we wouldn't know 7 pi over 12 without a calculator. But now you could look at that as two angles added together, two angles that we know. So maybe it's like, again, you know, pi over 3 plus pi over 4 or something like that. So I'm not going to show you that again just because this video is getting long. Let's move on to our last identity. Looks like we have two more. The sine sum identity, using our new identities in cofunction identities. All right? So our new identity is going to be the cosine of, you know what, I think we should do these in class because I think this video is getting long. We can finish these up in class. Okay, we'll stop here.